Good afternoon. So last class, what we have seen over on it, Abdina, we have seen the what are all the components of robots. Okay. So we'll have a controller, variation, size and shape, sensors, and end effectors and tools. Okay. So today's what we are going to see about Abdina. We are going to see about laws of robotics. Okay. So we all know that there is Isaac Asimov. Isaac Asimov, so he has framed or he has said that three laws of robotics. So I have given the thing that is survive, obey, protect. Okay. So this is the major thing that you can able to remember. Survive, obey, and protect. Okay. So we can go with the last. The last one states. What does it say, Sabina? So when we are defining any robot, when we are defining or when you are designing any robot, it may not injure a human being or through inaction or allow a human being to come to harm. So that is the thing first thing. Okay. So it has to be goes for with the robot may not injure a human being or through inaction or allow a human being to come to harm over that. And next, when you're going for law 2, okay, so it must obey the orders because that is the first thing, okay, which is given by the human being, okay, except where such orders would conflict with the first law. So, in the same thing, that it should not injure the human being, okay. So, the robot must obey the orders given it by the human being. That is the second law. And the third law is a robot must protect its own existence as long as such protection does not conflict with the first or second law. So it has to protect its own existence. Okay. But same time, it has to be obey the orders given by the human beings. Similarly, it should not injure the human being. So this is the things which has been defined by the Isaac Asimov's laws. Okay. And when we are saying about so these are the three laws which has to be constantly followed when we are designing a robots. Okay. The next we have to see about what are all the different types of joints for the robotics. Okay. So when we are saying about different types of joints, so we'll have 5 types of mechanical joints. So in the case of joints, actually it can able to provide the motions of the robotics. So we'll have a two different motion, one to be the translational motion and other one to be the rotary motion. Okay. In the different 5 types of joints, so what they have said that Abdina, among the 5, the 2 will be providing the translational motion, whereas the 3 will be providing the rotary motion. 2 will be providing translation and 3 will be providing rotary motion. Okay. So let me see what are all the joints available over on it. We'll have a linear joint, orthogonal joint, rotational joint, and a twisting joint, and finally we'll have a revolving joint. What are that? LORTB. You can remember that. What are the things? LORTB. Linear, orthogonal, rotational, twisting, revolving. Okay. So in among LORTV, whereas L and O will provide the translational motion. So in the thing that the input and output links will have over on it. So this can be made as a parallel or a perpendicular. If you are making it as a parallel, it go for a linear joint. If you are going for a so orthogonal, so that is go for a perpendicular. Okay. So these are the two different things I have shown in the diagram A and B. That is whereas the input link and output link which has been motion it has been linked with the given the parallel and perpendicular. Whereas in the case of a rotational joint, so the axis of rotation is perpendicular to the input and output. So rotary, we have to define the axis of rotation. Okay. So in the case of perpendicular Abhina, we can go for rotational joint. If it is a parallel Abhina, we can go for twisting joint. That is in the case of revolving வந்து பாத்தீங்க அப்படின்னா இன்புட்க்கு parallel இருக்கணும் அவுட்புட்க்கு perpendicular இருக்கும். So இந்த மாதிரி இருந்தது அப்படின்னா we can go for an revolving. Okay, what are all the different types of joints? We'll have a linear joint, orthogonal joint, rotational joint, twisting joint, and revolving joint. Okay, good. The next one, classifications of robots. So we'll have a Cartesian coordinate, we'll have a cylindrical coordinate, we'll have a spherical coordinate, we'll have a articulated coordinate, and we'll have a SCARA. SCARA explains for selective compliance assembly robot arm. Okay. So these are all the coordinates which has been given for the classifications of robot. Okay. So articulated, we'll see that. So articulated, so this design will feature some rotary joints, and it can range from simple to two joint structures to 10 or more joint over on it. Okay. So in this thing, what will have it of Abdina, the arm will be connected to the base with a twisting joint. Okay. The links in the arms வந்து பாத்தீங்க அப்படின்னா they are connected by rotary joints. So each joint பேர் என்ன சொல்லுவோம் அப்படின்னா it is called an axis, and it provides an additional degree of freedom or range of motions over on it. So we'll have a industrial robots commonly will have a 4 or 6 axis. Okay. So we'll have a range from simple two joint structures to 10 or more joints. So which will be connected to the base with the distinct joint. So we'll have a connected by rotary joints, so which is called as an axis and provides an additional degree of freedom. So we'll have a commonly 4 to 6 axis over it. Whereas in the case of a Cartesian coordinate, so we'll define it can be also called as rectilinear or gantry robots. So Cartesians nale will have a three linear joint. There is a Cartesian coordinate system. Will have a x, y, and z. And apart from that, they have an attached wrist to allow for rotational movement. So we'll go for a rotational movement over here, and we will have a three prismatic joints which delivers a linear motion along the axis. The third coordinate is about the cylindrical coordinate. So the robot should have at least one rotary joint at the base, and will have at least one prismatic joint to connect the links. Okay. So the rotary joint, what it does it, Abdina, it uses a rotational motion along the joint axis, whereas the prismatic joint, when the Abdina, it moves in a linear motion. So the robots which operate with a cylindrical shaped work envelope over on it. So these are about the cylindrical thing. The next one to be the polar. So it is also called as an spherical robots. So in this configurations, the arm one connected to the base, and similarly the arm is connected to the base. So whereas in the case of an polar coordinates, it also called as spherical robot. So in this configuration, the arm is connected to the base with a twisting joint and a combination of two rotary joints and one linear joint. So the axes form a polar coordinate system, and it will create a spherical shaped work envelope. So whereas in the case of an SCARA, so it is commonly used in assembly applications. So this selectively compliant form for robotic assembly in primary cylindrical end design. So it features two parallel joints that provide complaints in one selected plane. So I have shown over here, selective complaints assembly robot arm. So we'll have a see that two joints, three joints, four. Okay, we'll have a four joints. So we'll have a base. So they'll be complaint arm for the robotic, just primarily cylindrical design. So we'll have a two parallel joints which is in one selected plane over there. And the next thing is to be the delta. So delta வந்து பாத்தீங்க அப்படின்னா it is in the form of spider like robots. Okay, so we'll have a jointed parallelograms which connected to the same base. நடுவுல அந்த base இருக்கு பாத்தீங்களா, அந்த baseல இருந்து we'll have a parallelograms over on it. So we'll go for a single EOT in a dome shaped work area, and we'll have a heavily used in the food, pharmaceutical and electronic industries. So this robot configurations வந்து it is capable of delicate, and we'll have a precise movement. Okay, so these are all the classifications of robot. So far today's class we have seen what are all the laws of robotics. So we'll have a three laws. So you can able to say survive, obey, and protect. That is, it does not injure any human being. At the same time, it has to obey the human orders, and similarly, finally, it has to protect its own existence. We'll have a 5 types of mechanical joints. So among that, 2 will be providing a translational motion, and 3 will be providing a rotary motions. So we'll have a linear, orthogonal, parallel, perpendicular, rotary, perpendicular to input, and rotation, twisting joint, parallel to the axis, revolving joint, parallel to input but perpendicular to the output. Okay, and we'll have a classifications of robots: Cartesian, cylindrical, spherical, articulated, and SCARA. So articulated will have a 10 or more joints. Cartesian will have a 3 coordinate system x, y, z. Cylindrical, at least one rotary joint at the base and at least one prismatic joint to connect the links. Whereas polar, which connected to the base with a twisting joint and a combination of 2 rotary joints and a 1 linear joint. And finally, we'll have a SCARA. So SCARA selectively compliant term for robotic assembly, primarily cylindrical in design. Finally, we'll have a delta, which is in the form of a spider-like robots. We'll have a single EOT in a dome-shaped work area. Okay, so the remaining thing we can see in the next class.